One, do you hear me?
Good morning po,
Yes
sir.
po, sir.
Yes po, sir.
Yes po, sir.
Okay, so please open your camera. So today we will be continuing our discussion on diesel electric power plant. Now we will be having our performance analysis. So last week, okay, we introduced be analyzing its performance. So there are several parameters that need to be considered in in analyzing the performance of a diesel engine power plant. First, we have to consider the different power outputs. First, we have the indicated power. So indicated power is basically the power developed at the engine cylinders. Okay. And then we have the brake power. So this is basically equivalent to the shop power. Okay. So, and then we have your electrical power output. Okay. So this is your megawatt rating. Okay. So this will serve as our plant capacity. Okay. So from indicated power, no, nagiging brake power siya, and then nako-convert natin into electrical power output. But take note that we need to define our mechanical efficiency and generator efficiency. Okay? By considering arrow technique, we were able to develop our arrow diagram. Okay? So this is your IP, this is your BP, and this is your EP. So in between IP and BP, we can measure your mechanical efficiency. Between brake power and electrical power output, we can measure our generator efficiency. And considering efficiency as output over input, so mechanical efficiency is basically equal to your brake power over indicated power. Okay. Sabi nga natin, if your mechanical efficiency is 100%, then IP is equal to your BP, but it cannot be. Okay? Mechanical efficiency should always be or less than, no, 100%. No, because of inefficiency. So basically, your BP, no, is not equal to your IP since there is fractional power. Okay, so meron tayong na-measure dito na friction power. Okay? And then of course, yung generator efficiency cannot be equal to 100%. And therefore, your generator efficiency is output over input, so EP over BP. We can also measure the overall efficiency. Overall efficiency is basically a function of your mechanical efficiency multiplied by your generator efficiency. If you're going to substitute by checking, no, your overall efficiency is output over input. Okay? If you're going to substitute your mechanical efficiency, which is BP over IP, and then your generator efficiency is EP over BP, BP will cancel out and it will be resulted into EP over IP. So yun yun. So ito yung tatlong parameters nating ini-evaluate, no? First is the power output. So in terms of IP, BP, and EP, this is serve as our general relation, no? In terms of mechanical efficiency and in terms of generator efficiency or even overall efficiency. Okay? So last time to review, we define our indicated power as a function of your indicated mean effective pressure times your volume displacement. So volume displacement is just a function of LAN, no, or LAN S. Okay, your NS is 2 pan over S, no. So yung C natin dito is the number of cylinders acting. Okay, then N is RPM and S is the number of stroke. Okay, so if we are going to trace, no, in the PB diagram, okay, if you can recall, in the diesel cycle, we have your SPSB, no? So process 1 to 2 is basically isentropic compression, and then process 2 to 3 is basically heat addition at constant pressure, and then 3 to 4 is isentropic expansion, and process 4 to 1 is isometric heat rejection. Okay? So if we are going to trace the area, no, being covered by by the PB diagram, this is basically your work. This is positive, work done by the system. Okay? So kung iti-trace natin siya, we can have our indicator diagram or indicator card. Okay? This serve as our area ng card natin. If we define the length, so ito yung length ng ating indicator diagram, okay? And then we have your spring scale. So we can measure your PMI, no, your indicated mean effective pressure, which is equal to your area, okay, of the indicator card times your spring scale over the length, no, the length of the card. Okay? If we can also consider the TS diagram, we can measure the maximum. It's very obvious that the maximum temperature, okay, in the TS diagram for diesel cycle, okay, T max is equal to T3. No? Your maximum temperature is basically your T3. Your maximum pressure is P2 or P3. So P2 is equal to P3 and B max is equal to your B4 which is equal to your B1. No? So yan yung ating mga maximum conditions. Maximum temperature, maximum pressure, and maximum volume. Okay. If we are going to compare your diesel cycle into gasoline cycle, which is basically your auto cycle, so nagbago yung ating heat addition, no, process. So instead of isobaric process, we can now have the isometric process. So meaning your process 1 to 2 is isentropic compression, your process 2 to 3 is your isometric heat addition, okay? Process 3 to 4, okay? Process 3 to 4 is isentropic expansion, and then process 4 to 1 is isometric heat rejection. So SB, SB. No, kanina ay SP, no, SP. Okay, so nagbago ito, naging volume na rin ito, constant volume yung heat adhesion. So SB, SB. Okay? Now, if we are going to define your friction loss, no, so nakikita natin in between your IP and BP, no, kaya your mechanical efficiency cannot be equal to 100% because of the friction power. So this serve as our losses, no? So kung titingnan natin yung relationship natin, your friction power is basically equal to your indicated power minus brake power. Or simply, your indicated power is brake power plus friction power. Okay? So yan yung ating relationship between the friction power, frictional power. No? The IP is equal to BP plus your frictional power. So palabas siya. This is losses basically. No? So, ano yung definition natin sa frictional power? Or friction power is the power dissipated in the machine through friction. Okay, by Morse test, we can determine the friction power. Or we have the applicability of test is for multi. Okay, Morse test is being used, okay, for multi-cylinder engine. If we are going to consider six-cylinder engine, no, kung six-cylinder engine, ano yung relationship natin? From the basic relation for indicated power, which is equal to your brake power plus friction power, anong mangyayari? So we have your indicated power for the six-cylinder, which is equal to your brake power for the six-cylinder plus your friction power. Okay? If we are going to consider the six cylinders are firing, so still we have this friction power. No? Kapag ka naman five cylinders lamang yung firing, the same friction power can be measured. Okay? So meaning, this is your IP for five cylinder, which is equal to your brake power, okay, for five cylinders plus your friction power. Okay, anong napansin ninyo? Your friction power are basically constant or basically the same no matter how many cylinders are firing. So therefore, your friction power is constant no matter how many cylinders are firing. Okay? So isa lang yun, pareho lang siya. No? If you are going to cancel out this one, no, pag minus natin ito, IP6 minus IP5 is IP. No? And your BP6 minus BP5, this will cancel out yung iyong friction power. So that would serve as your IP. No? Now, we can consider also your brake power. How can we measure your brake power? We can consider the use of brake mean effective pressure. Kung meron tayong indicated mean effective pressure, we can have also your brake mean effective pressure. No? If we are going to multiply it by volume displacement. Or simply, your brake power is just a function of your 2 pi Tn. No, because this is a shaft power. Okay, 2 pi Tn. Torque, ito yung torque natin. F, yung force applied, times yung radius ng shaft natin. Okay? And N represents your operating speed or RPM. No? So 2 pi Tn over 60, no, is the brake power. Okay? So yan yun. Kaya brake power is simply a shaft power. Okay, machine design. Okay? So kung titingnan uli natin, this is the flow. No, this is the flow of power. Laging palabas siya. Okay? From IP to BP to EP. Okay, finally your EP is your electrical power output. Ito na yung pupunta sa ating transmission and distribution system. This is basically your plant capacity, your megawatt power output or kilowatt power output. Yun ang definition ng ating EP. Okay? So EP is the generated power, no? Generated power siya. This is defined also as a power delivered at the generator terminals. Okay? So how can we measure your EP? So there are methods of measuring EP. First, we can do kilowatt hour test, no? Tetest natin yung kilowatt or we can measure your kilowatt hour. So before and after or start at the end of test we can measure. So ano yung iyong kilowatt hour at the start of test and what would be your kilowatt hour at the end of test over the number of hours test. Okay? We can measure your EP. We can measure your EP. So it could be in kilowatt or it could be in megawatt hour minus megawatt hour over number of hours. So your EP is in megawatt, no? So yun yung ating first method. We can conduct, no, kilowatt hour test. We measure at the start, we can measure at the end, and then we divide the number of hours. Okay. Another thing is through the use of field test. No, field test. So meron tayong tinatawag na voltmeter, ammeter method. No, we can measure the voltage, we can measure the current, no, through ammeter. So we can have or we can use the equation simply by square root of 3 EI cosine P over 1,000. No? So mapapansin mo, if you have your square root of 3, this is equation is good for three-phase generator. No? So divided by 1,000 to make it kilowatt. To make it kilowatt. No? Kasi itong A yung E dito is basically your voltage per stroke. No? Voltage per stroke and your I is basically current per stroke and cosine P is your power factor. Okay? So the unit that can be derived here is kilowatt. No? Pagka single phase naman, single phase generator, nawawala yung square root of 3. So this is simply EI cosine P over 1,000. No? So we can measure your EP. So dalawa na yung method natin. First, kilowatt hour test. The second is field test. No, we measure the voltage, we measure the current. Okay, we can compute for EP. The third one is the generator data. No, so titingnan natin ano ba yung KVA rating niya. If you have your KVA rating, it is being multiplied by your power factor, we can simply get your EP. No, so KVA times your power factor. Now, the next parameter that we need to evaluate, no, to determine the performance of your diesel electric power plant is the thermal efficiency. This is a very important parameter, okay, in the diesel engine performance. Okay, so we define thermal efficiency as a function of your heat equivalent, the power over the heat supply, no, the heat supplied by the fuel. No, so heat supply is being defined as a function of your mass ng fuel times your calorific value or heating value. Okay? So if we are going to measure your indicated thermal efficiency, no, are you still there? Nakakasunod ba kayo? Hmm? Your indicated
Opo,
thermal
sir.
efficiency, you have your IP, no? Ito yung heat equivalent natin or the power, okay? Over your heat supply, which is your MF, your heating value. Kung i-measure naman natin yung brake thermal efficiency, so the power that we are going to consider is the brake power over your MFHB. So pareho lang yung heat supplied mo. Okay? But nagbabago yung ating heat equivalent. No? Kung indicated thermal efficiency, we will use indicated power. If we have to measure your brake thermal efficiency, then we will be using your brake power. And then finally, we have your combined thermal efficiency. So E sub K. So in combined thermal efficiency, we will be using your EP. No? EP, your electrical power output over your MFHB. Okay? So yan yung ating equations for thermal efficiency. Now, we define your heat supplied. No? We define your heat supplied as a function of your mass of fuel burned or mass of fuel consumption. Okay? So it could be in terms of kilogram per hour or kilogram per second. And then we have also the heating value or calorific value ng fuel. Ano ba yung fuel na ginagamit natin? Again, we have your diesel fuel, no? A petroleum-based product. Okay? So diesel fuel will be used as your fuel. So doon mo i-define yung calorific value niya, and then we can measure your amount of fuel, and then that will serve as our heat supply, no? So mass of fuel times your heating value or calorific value, that is kilojoules per second or kilojoules per hour. Simply kilojoule per second is kilowatt, no? So how can we measure your heating value? No, dalawa kasi yung tinatawag nating heating value. First is the higher heating value, no? We can compute the higher heating value, no, using Bureau of Standard formula. This is just a recall, no, combustion engineering, no. If you are given your specific gravity at the standard condition, so we define it as SGS, no. There are two equations involved. First, we use the BTU per pound, the English units, and the other one is the higher heating value in terms of kilojoules per kilogram. Okay, so these are numerical values, no, which are we have 22,230 minus 3870 SGS squared. No, if you know your standard or gravity, specific gravity at the standard condition, then we can simply substitute your SGS and we define your HHB in terms of BTU per pound. However, if you are given also in terms of if you are using an SI units, no? So you have your 51,716 minus 8793.8 SGS squared. This is simply kilojoules per kilogram. Okay? So, how can we measure your SGS? No, paano ba natin measure yung ating specific gravity at the standard condition? So there are two methods. If you are given your degree API, the fuel rating, the API rating, no, American Petroleum Institute. So if you know your degree API of the fuel, then you can use 141.5 over 131.5 plus degree API. However, if you are given your degree BOMI, no, you can simply compute your SDS as a function of 140 over 130 plus degree BOMI. No? Now, if we are going to evaluate your specific gravity of the fuel at a given temperature, no, at a given temperature. So meron tayong tinatawag na temperature correction factor. No, it is being multiplied to your standard condition, specific gravity at the standard condition. So the specific gravity of the fuel is equal no to CT, no, your temperature correction factor, no, times your SGS. No, how can we define your CT? So meron tayong, if you're given your degree Fahrenheit temperature of the fuel, then we have your temperature correction factor, which is equal to 1 minus 0.00004 times your degree Fahrenheit minus 60. No? 60. So this is your reference temperature. However, if you are given your degree Celsius, then 1 minus 0.0007 times degree Celsius minus 15.6. So we can now compute your specific gravity of a fuel at a given temperature, whether in degree Fahrenheit or in degree Celsius. Okay? Now, if you are given your degree API rating, we can also compute your higher heating value. No? So there are two methods. No? First is in terms of BTU per pound, and another one is in terms of kilojoules per kilogram for SI units. So we have 17,680 plus 60 degree API or 60 times your degree API. So this will yield BTU per pound. Kapag naman kilojoules per kilogram, we have 41,130 plus 139.6 degree API. So this is in terms of kilojoules per kilogram. No? So kanina, ginamit natin yung equation natin, Bureau of Standard Formula for HHB. The second formula is in terms of degree API. We can compute for HHB also. And the last one is your ASME formula. No? So meron tayong American Society of Mechanical Engineers formula for computing higher heating value. Now, in for to compute your higher heating value, we should know the ultimate analysis of the fuel. So dapat alam mo, okay, yung ultimate analysis. Okay? Ultimate analysis are basically your elemental analysis. So usually ultimate analysis is in terms of gravimetric analysis, no, by mass, no? So if you have your elemental composition, no, di ba meron tayong carbon, meron tayong hydrogen, oxygen, nitrogen, sulfur, ash, and water. Okay? So we will get the percentage composition of carbon, say your hydrogen, also your oxygen. Chonso. Okay? So titingnan natin ngayon ito. Say for example, you are given your ultimate analysis, say your carbon is 80% carbon, no? So we can multiply here, yung carbon natin dito is 33,820 times 0.8 or 80 over 100. Kasi percentage ito. So it should be 80 over 100 kaya 0.8. Likewise for hydrogen, no, say you are given 3% hydrogen, no, ilalagay mo dito is 3 over 100, no, likewise for oxygen. Okay, ito naman merong sulfur plus 9304 times sulfur. May sulfur ito ha sa dulo, no, times S, yung sulfur doon sa elemental composition, plus 9304 sulfur. Okay, so this will yield kilojoules per kilogram. I repeat, 33,820 times your carbon from the ultimate analysis, 144,212 times your hydrogen minus oxygen over 8. Hydrogen and oxygens are also taken from your ultimate analysis, 9304 times your S. And S should be taken also from your ultimate analysis. Okay. Now, if you are going to use, no, the equations for BTU per pound, if you are working on the English units, then you have your 14,600 times your carbon. Ganun pa rin. Kung ang carbon mo is 80%, so this should be 8.8. No? Then we have 62,000. Take note, 62,000 times your hydrogen minus oxygen over 8 plus 4050 times your sulfur. No, parang doon. 9304 times your sulfur. No? This is in terms of BTU per pound, but it's still, no, this is your percent over 100%. No? So decimal dapat siya. Okay? So ano yung relationship natin, no? Between your higher heating value and the lower heating value. Ano ba yung pagkakaiba? No? We can compute your lower heating value as higher heating value minus, no? So subtract natin yung latent heat required in the formation of water vapor. Okay? Kaya pag itinanggal natin yun, no, sinubtract natin from the higher heating value, no, it will become lower heating value. No. So what would be your latent heat required in the formation of water vapor? This is a function of your mass of water vapor times your HFG. No? Your enthalpy by evaporation. Yung Hg minus Hf natin. You're going to take a look on your steam tables. No? Makikita mo doon yung Hg, makikita mo yung Hf. You get the difference that serve as your HFG. No? Now, we have the value of HFG, no, which is at 25 degrees Celsius and 77 degrees Fahrenheit. No, kung ikaw ay gumagamit ng English units, then you will be using 1050 BTU per pound as your HFG. No? While if you are in the SI units, then you will be using 2,442 kilojoules per kilogram. No? So what is your 25 degrees Celsius or equivalent to 77 degrees Fahrenheit? So this is your combustion-based temperature. Naririyan pa kayo o baka kayo ay tulog na. Ha? Naririyan pa kayo?
Dito po po, sir.
Okay. So, pag minultiply mo ito, so this will be your HFG if you are going to multiply this from your mass of water vapor. So, siya ay magiging kilojoules per kilogram. It could be in terms of BTU per pound. No? So, paano natin naman i-compute yung mass ng water vapor? This is simply 9 times percent H2. No? Yung percent H2 will be taken from the ultimate analysis of fuel. No? 9 times percent H2. Okay? So, paano natin kinuha yung 9? This is basically 18 over 2. No? Kung gumawa ka ng combustion equation, hydrogen plus oxygen, no, will form water. Hydrogen will oxidize to form water. No? So, ganyan yung nangyayari sa ating combustion equation. Okay? So, we have 2 plus 16, no, at the reactants, okay, will yield 18, no, moles at the product. No? So, may inaano natin yan. Nagkakaroon tayo ng balance. No? Binabalance natin yung equation natin. No? So, we need 18 kilogram, no? 18 kilogram per mole, no? Per 2 kilogram of hydrogen. So, that would serve as your 9 times percentage. Okay? Yan. So, kung ilalagay ngayon natin dito using your arrow diagram, no, balikan uli natin yung ating no, yung mga equations natin diniscuss are basically articulation of the different parameters used, no, in the thermal efficiency equation. No, kung ilalagay natin ito sa ating arrow diagram, yung indicated thermal efficiency, then we have your break thermal efficiency, and then the combined thermal efficiency. Ano mangyayari? No? So, ito yung magiging arrow diagram natin. This would be your E sub I, E sub B, E sub K. Anong napansin ninyo? Anong napansin ninyo doon sa arrow diagram? Huh? What did you notice? No? Di ba ang originally, ang ating arrow diagram is a function of your power outputs. Di ba? Kanina, ipinakita ko sa inyo yung power outputs natin. This one, your IP, your brake power, and your EP. No? That would define your mechanical efficiency and your generator efficiency. O, balikan uli natin ito. Yan, ito yun. No? Ngayon, instead of using your power outputs, we can use your thermal efficiency. No? Your indicated thermal efficiency, your brake thermal efficiency, and your combined thermal efficiency. But still, we can measure both mechanical efficiency and generator efficiency, or even your overall efficiency. No. So tingnan natin ngayon, how can we derive? Again, so ang kailangan nating tingnan ay yung bang pag ginamit natin yung thermal efficiency, no, as our performance parameter, no, may ibalik ba natin yung equation natin sa mechanical efficiency on the original relation that BP over IP is mechanical efficiency and your generator efficiency is simply EP over BP and your overall efficiency is EP over IP. So these are the general equations natin for mechanical efficiency and generator efficiency. Ngayon, gamitin natin yung thermal efficiency as our performance indicator. Okay, yan. So anong nangyayari natin? Inyong ang balikan. Oh, okay. So yan. So kung ito ngayon ang EI mo, this is your brake thermal efficiency and this is your combined thermal efficiency. No? We can measure your mechanical efficiency as output over input. So EB over EI. Okay? Nakuha nyo? Then generator efficiency is output over input, EK over EB. No? Ngayon, kung titingnan mo yung overall efficiency natin is EK over EI. Yon. So, pag kinuha natin ito ngayon, no, EV over EI, we can substitute. Sabi natin kanina, we define our brake thermal efficiency as the heat, no, generated, no, heat equivalent or the power over your heat supplied. So BP over MF HB. Then EI, we have IP over MF HB. So MF HB or heat supplied, no, will cancel out, no? Anong matitira? Your BP over IP. So, bumalik tayo dun sa original equation natin. No? So, tama. Tama yung relation natin na ang mechanical efficiency is a function of brake thermal efficiency over your indicated thermal efficiency. So, ibig sabihin, pwede mong i-measure yung mechanical efficiency mo without knowing your brake power and IP. No, pag alam mo lang itong brake thermal efficiency, indicated thermal efficiency, we can directly measure your mechanical efficiency. So, ganun din yung generator efficiency. Output over input. Okay? EK over EB. No? So, if we can substitute now, your combined thermal efficiency is a function of your EP over your heat supply. Okay? Your EB is brake power over heat supply. No? So, magka-cancel out uli yun and it will yield EP over BP times 100%. Diba? So, ito pa rin ang equation natin. No? Naroon pa rin sa original relation natin, EP over BP. This is just a checking. No? Overall efficiency is EK over EI. So, ganun pa rin. So, EP over IP. Gets ba ninyo yung thermal efficiency? Nakuha ninyo?
Apo, sir.
Okay. Let us proceed with the next parameter. We have engine efficiency. So, how can we define engine efficiency? Ito naman yung gagamitin natin as our performance indicator. Kanina, power developed. Second is the thermal efficiency. And now we have the engine efficiency. Okay. Now, meron tayong dinidefine also na indicated engine efficiency. We have also brake engine efficiency. And we have also combined engine efficiency. No? I repeat, we have your indicated engine efficiency, we have brake engine efficiency, and combined engine efficiency. Okay. Now, ano yung relationship natin? How can we define our indicated engine efficiency? Paano? So, if we know our indicated thermal efficiency, and we define the overall thermal efficiency or the plant thermal efficiency, no? And that would serve as your indicated engine efficiency. Okay? Ganun din yung iyong brake engine efficiency. This is a function of your brake thermal efficiency over your plant thermal efficiency or overall thermal efficiency. Okay? And then combine is your combined thermal efficiency over your plant thermal efficiency. So, yun naman ang gagawan mo ng arrow diagram. No? Yun naman ang gagawan mo ng arrow diagram. And using arrow technique, no, we can we can define our mechanical efficiency and we can define our generator efficiency. Tingnan natin. So this would be your NI, your indicated engine efficiency. This is your brake engine efficiency. And we have your combined engine efficiency. Okay, balik ulit tayo. Mechanical efficiency is output over input. So your output is your brake engine efficiency and your input is your indicated engine efficiency. Take note na, hindi pwedeng mabago yung flow ng arrow natin, yung direction ng arrow. No, hindi pwedeng bumalik. No, take note ha, we are producing power. Hindi pwedeng pabalik yung arrow. Okay? This is, pag pinabalik mo yung arrow, that is a big violation. No? Laging palabas kasi power output. Power output. Take note, the diesel engine, no, develops mechanical energy which shall be converted into electrical energy. So, hindi pwedeng bumalik. Laging from indicated, nagiging brake, nagiging combined. Okay? So, ganun. So, NB over NI. NG is NK over NB. NO is NK over NI. Oh, ngayon, inyo nga gawin dyan sa inyo on your seat. No? Gawin nga ninyo, ibalik nga ninyo yung mechanical efficiency into original equation. No? Sige, inyo nga gawin and then tatawagin ko kayo and you present your derivation. Okay, ibalik ninyo itong mechanical efficiency ito into original relation na brake power over indicated power using your brake engine efficiency and indicated engine efficiency. Sige, go. Kung naiintindihan ninyo yung ating pinag-usapan. Renz Arvin, ikaw yung magpe-present. Sige, go.
Wait lang po, sir. I-picture ko lang po.
Ibalik mo yung equation na yan into brake power over indicated power. Likewise, your generator efficiency into EP over BP. Yung iba ay magawa din. Baka mali rin i-present na rin si Renz Arvin. Magtatawag uli ako. So mamaya, magsosolve kayo ng problem, you will be applying this relationship. Depende sa given na parameter. No? Kung thermal efficiency, then you will be using your arrow diagram for thermal efficiency. If you're given your engine efficiency, then you will be using this arrow diagram.
Hello po, sir.
Okay, go. We share it.
Kita po ba, sir?
Sige, go.
Um,
Discuss. Present it. Sige. Nakikita ko na.
from our mechanical efficiency po, we have our formula, yung brake engine efficiency over indicated engine efficiency. And we know we know po na ang ating brake engine efficiency ay equal po sa ah, EB over ET,
Ano
and
ba yung AB?
yung atin pong generator efficiency
Oh, sa
or
pagkita, AB.
thermal efficiency
AB.
po, yung brake thermal
Brake
efficiency.
thermal
Opo,
efficiency. Huwag mong ilahok-lahok.
sige po. Yung brake thermal efficiency po over yung atin pong total thermal efficiency.
Total, overall. Overall
Overall.
or plant thermal efficiency. Hindi
And
total. Hindi
then
mo pwedeng
our
i-add ka ang thermal efficiency. Go.
ano naman po, indicated generator efficiency or
Oh,
indicated engine efficiency po pala.
hanggang nalilito ikaw.
Sorry po.
Indicated
Indicated
engine
engine
efficiency.
efficiency
Wala pa diyang generator.
ay equal po sa ating indicated thermal efficiency over overall thermal efficiency.
Hmm.
And then magka-cancel out po yung overall thermal efficiency, and
Hmm.
matitira po ay yung ating brake thermal efficiency over indicated thermal efficiency.
Okay.
And then kanina po we discuss na ang atin pong brake thermal efficiency ay equal sa brake power over yung heat supplied.
Heat supply. Okay.
Opo. And then yung atin pong indicated thermal efficiency ay yung atin pong indicated power over heat supplied, and then maka-cancel out po yung heat supplied at babalik po dun sa formula po na brake power over indicated power po.
O sige. Very good. So, napabalik mo yung mechanical efficiency into our original relation. How about generator efficiency? O, Daniela, go. Oh, share your screen.
Sir, wait lang po.
Oh, Daniela, where are you?
Sir, wait lang po. Pipicturean lang po.
Hmm. Baliktad. Ano ka ano? I-rotate. Ganun pa rin. Yan. Okay. Oh. Discuss.
So, sir, ay,
Hindi kita napapakinig, nakamute ka, Ining.
Hello po?
Okay, go ahead.
Yes,
Nagkaano ka
ma'am.
dyan? Sige,
Yes,
echo ka.
ma'am.
Nasaan ka dyan?
Alis mo pa ako. Ah, dito ka mag-icon.
Nasaan ka dyan? Maagas-as
Hello
ka.
po?
Oo, maagas-as ka. Para kang si Ani maagas-as.
Okay na po?
Okay, go.
Wait lang po.
Discuss. Discuss.
So, sir, para po sa generated efficiency po,
Hmm.
we have combined efficiency over rate efficiency po. And then,
Bagay yun na ang iyong ano. Ba't na-shortcut na ang iyong term?
ay, so for generated efficiency po, meron po tayong,
Oh.
sorry, meron po tayong combined,
Combine ano?
meron po tayong combined,
Combine.
combined engine efficiency po, and
Yan.
then
Okay.
over brake engine efficiency po.
Yeah, yes.
Equals po
Okay.
tapos po ang combined engine efficiency po ay equals to combined thermal efficiency over brake thermal efficiency, and then yung brake engine efficiency po ay equals sa brake brake ay tama po, brake thermal efficiency over ay brake efficiency over brake thermal efficiency po. And then po, ang makakancel
Nakalito
po
ka na.
ang brake thermal
Iyo mo
efficiency.
nang anuhin. Nakakalito ang iyong sinasabi. O, balikan mo
Ay, sorry
muna
po.
ulit. Ano ba yung equation natin sa combined engine efficiency? Okay, sabihin mo muna yun.
Equals po siya sa engine thermal efficiency over
Ano
brake
kang
thermal
engine thermal
efficiency.
efficiency? Ba't naglabo-labo ka
Combined
na
engine,
yun?
ay, sorry po. Combined thermal efficiency po
Oh,
over
over.
brake thermal
O
efficiency po.
bakit ka naging, hindi, over gayon?
Opo.
Ha? Meron din yung ano ha? O ano ang equation natin? Wag ka muna pumunta dun sa brake. Doon ka muna sa combined engine efficiency. Ano yung equation natin doon? Wag mong i-shortcut.
Ay, okay po.
Hmm.
Ah,
Kita
combined
mo doon.
thermal efficiency over thermal efficiency po.
Ano?
Combined thermal efficiency over thermal efficiency.
Ano yung thermal efficiency yun? Bakit thermal efficiency lang ang sinasabi mo? Ano ang ating definition doon sa E sub T?
Overall thermal efficiency po.
Yan.
And
Tatanda.
then, okay po, sorry po sir. And then brake thermal efficiency over overall thermal efficiency po.
Anong
And then
sunod?
makakancel po ang overall
Yan.
thermal efficiency.
Anong
So,
matitira?
ang matitira po ay yung combined thermal efficiency over brake thermal efficiency po.
Yan.
And then ang combined thermal efficiency po ay equal sa uh,
Mm.
EP over MFHB po. Or yung generated power po over sa heat supplied po.
Mm.
And then, ang EB naman po ay equal sa brake power over heat supplied po.
So
And
ano
then,
na naging
maka-cancel
equation?
po ang heat supplied. Magiging EP over BP na po siya, times 100%.
Yan. So that would be your generator efficiency. So yung overall efficiency natin, you can also derive using your engine efficiency. Okay. So let us go back. No? Yan. So yan na. Kuha na ninyo. Yan. So ito yung ipinakita ninyo kanina. This is your checking. Oh, ngayon, ang sunod na parameter natin or indicator is your specific fuel consumption. Specific fuel consumption is defined as the mass of fuel, no, used, or the amount of fuel consumed, no, for every kilowatt hour produced or energy generated. So kilogram per kilowatt hour. So that would be your definition for a specific fuel consumption. Ngayon, if you are going to measure your indicated specific fuel consumption, so meron tayong relation na 3,600 times your MF over IP. Oh, mass ng fuel over your indicated power. No? So this is just conversion factor, yung 3,600. No? So pagka naman brake, we have brake, specific fuel consumption, no? Yung MB natin. So 3,600 MF over BP. And finally, we have combined specific fuel consumption, which is equal to 3,600 MF over EP. Okay. Your task is to prepare now the arrow diagram and you derive the relation. Ibabalik uli ninyo yung mechanical efficiency and generator efficiency sa original and you derive the relation. Okay, go. Sige, gawa kayo on your seat. Oh, kasi kasi tatawagin ko uli kay mamaya para mag-present. Yan. So these are the equations for the three fuel consumption. Okay, go. MI, MB, MK. O, nagbabago lang naman yun. Ito lang yung nagbabago. MF, constant siya. Pare-pareho lang yan. Okay, so your task is to prepare the arrow diagram and you derive the relation. Okay, go. Oh, mag-prepare ka ha, Curl Vincent. Ikaw ang una kong tatawagin.
Okay po, sir.
And then, ikaw, sunod na magpe-present ay si Albert John Arellano. Nariyan ka baga? Albert? Nawala na si Albert. Sige. Yun. May talaok ng manok. No? Oh, sige, go. Yan. Share mo mamaya ang share ninyo mamaya ang screen nyo and then you discuss. So you draw first the arrow diagram indicating the given parameter. So ano yung parameter natin or indicator? Specific fuel consumption. So yun ang dapat makikita ko sa arrow diagram. Prepare din yung iba ha. Baka mali ang i-present nitong dalawa. Okay, siyempre magtatawag uli ako. Gumawa kayo ng inyo para ready kayo. Di ka pa tapos. Pearl,
Na-finalize pa po. Wait lang po.
let me share your screen.
Imposter. Yun po yung sa arrow, yun po yung sa arrow technique po.
Okay, palakihin mo ng kaunti. Yan, zoom mo. Sige, go. Hmm.
Yun po. Start po sa 1 over yun sa mass fuel efficient, yun sa mass fuel po.
Ano kang mas fuel? Ba't gagayon ang iyong ano? Ano ka ang
Sa
MR?
indicated specific po na mass fuel.
Ano kang mas fuel?
Wait lang,
Mali,
okay, nalilito lang po ako sa terms. Wait lang po.
basahin mo uli ring ano ha.
Sige nga.
Hmm.
Yung sa indicated po. Indicated fuel, specific fuel consumption po pala.
Hmm.
Di, yun po. Tapos i-going through po dun sa... Mali pa. Hindi pa. Sa brake specific fuel consumption po.
Battery MK.
Mali po ang sulat ko. That way, NAB.
Ha?
Mali po ang sulat ko. Nagkamali po.
Ay, ano are?
Yun po sa gitna po dapat ay 1 over MB.
Hmm.
So, yun po. Ang po pagkuha sa... Tapos ipapunta po siya sa, yun po, sa last po sa specific, sa combined specific fuel consumption, which is 1 over MK. Tapos po ay forgetting, para po kunin yung yung mechanical efficiency, ay yung sa MB over MI. Yung MB ay po, brake specific fuel consumption, tapos ay yung MI naman ay indicated specific fuel consumption. Tapos ay based po doon sa inyong sa inyong pinakita kanina formula for MB, which is 3,600 MF over BP. Tapos po ay yung sa MI naman, yung sa indicated specific fuel consumption ay 3,600 mF over IP. Tapos ay pagde-divide po sila ng dalawa. Maka-cancel po yung 3,600 mF. Tapos po ay magre-result po sa sa IP over BP. Tapos po iti-take po ang reciprocal. NM equals to BP over IP. Yun po.
Tama baga are? Tama are Kyle Miguel Alcantara? Tama, wag mo munang itatanggalin aring iyong tama baga are?
Yung baliktad po yung sa akin.
Ano? Ang tanong ko lang, tama baga are o mali? Yun lang ang sagutin mo sa akin. Tama, mali. Aring kanyang ipinakitang aring derivation.
Tama po.
Ikaw Mark John.
Okay na
Tama
po, sir.
baga are o mali?
Tama naman po, sir.
Next.
Thank you po, sir.
Ikaw Althea. Tama baga are o mali?
Tama po, sir.
Tama. Yan siya. Pag ako naman ay yung tanungin, tama po ba sir o mali? Tanungin nga ninyo ako. Tanungin mo nga ako, Camille. Kung tama o mali. Sige, ask me.
Tama po ba, sir?
Mali. Mali ang sagot. Hindi lang basta nakapag-derive ha. Ang pag-derive ay tama ang derivation, dapat hindi nagmamagic. No? Kagaya nito. Ito ang sagot ha. Kita mo, ipakita ko sa iyo.
Sige
Yan.
po.
Yan ha, ito yung tamang arrow diagram. At ito yung derivation mo. Dapat ay 1 over MB over 1 over MI. Yun ang mechanical over MI. Bago magte-take ka ng reciprocal, sinong nagsabi sa yung taking the reciprocal? Ano? Ibig sabihin ng taking the reciprocal. Saang rule yun? Mali. So ito ang susundan ninyo. Yung ang gawa ng tama na ang arrow diagram mo pagdating mo doon sa pagdiderive ng equation minali mo na naging MB over MI yung gay MB ang nakita mo din Ha? Did you get my point?
Yes po, sir.
So pag inilagay mo kung ay 1 over MB over 1 over MI. So yun ang iyong i-work out na equation. Hindi yung MB over MI. Magkaiba yun. Tsaka tumingin ng MB over MI, hindi naman MB ang naririnig. Gets?
Opo.
Gawin mo nga. Itama mo.
Sige po, sir.
Ikaw Alcantara, ikaw Arellano. Tingnan ko nga ang iyong ginawa.
Represent ko lang po, sir.
Bago sasabihin ninyo tama yun, mali ha, mali. Ano naging tama yun? Obvious na obvious. 1 over MB over 1 over MI is mechanical efficiency. Generator efficiency is 1 over MK over 1 over MB. So yun ang working equation mo. Hindi MK over MB.
May kulungan pabubili tayo sa baba ng kalamay. Burning. Pwede. Pwede ka naman siya. Mapupili tayo sa baba. Hindi ka gano'n. Pumili na kayong kalamansi sa baba. Bumili kayo somay. Tapos hindi kaya nga. Dali. Baka may mga usap yun. Sir Alan, may kalamansi.
Sir, kita na ka po ang aking screen.
Albert John, nasaan ka na ka?
Sorry po, sir.
Anong ano? Share your screen.
Kita na po, sir.
Di pa. Hindi ko pa
Naka-share
nakikita.
ang screen.
O, sige, go.
Ito po, sir. Yung
Naku, kalabo utoy. Wala yung ilalaki pa yan. Malaki-laki nang makita.
kita na po.
Go.
Ito po ang generator efficiency po ay equal po sa 1 over combined specific fuel consumption over 1 over brake specific fuel consumption.
Mm.
Na yun naman pong MK is equal sa 3,600 mf over EP. Tapos, yun naman pong 1 over MB is equals to 1 over 3,600 mf over BP. Cancel lang po yung 1 over 3,600 mf na common po. Tapos, ang matitira na lang po ay EP over BP times 100%.
So, yun yung iyong generator efficiency. O, next. O, heat rate naman. Ito na yung last parameter natin. Heat rate is kilojoule per kilowatt hour. Okay? So, we can measure or we can compute heat rate by using your indicated specific fuel consumption times your heating value. So, ito yung indicated heat rate. Pag brake heat rate naman, ang gagamitin natin ay yung brake specific fuel consumption times your heating value. Likewise, your combined heat rate is oh, hindi
Sir,
na
excuse me po. Di po naka-present po. Ay, thank you po.
yon. Okay? So you have your MIHB, MBHB, so heating value. Ito yung indicated heat rate, brake heat rate. So ginamit natin yung MI, MB, MK. So combined heat rate. No? So ang unit ng heat rate natin is kilojoules per kilowatt hour. Okay. So kung titingnan mo uli ngayon sa ating arrow technique or arrow diagram, so siya ay 1 over indicated heat rate, 1 over brake heat rate, and 1 over combined heat rate. So you can derive again your mechanical efficiency and generator efficiency. Okay, go. O, ikaw ang gagawa naman. Dean Abraham at Adrian Gamboa. O, nariyan ka kayo? Pakinig ninyo ako.
Sige po, sir. Wait lang po.
Okay, you derive. You derive mechanical efficiency. So, parang kapareho din lang na yan ang specific fuel consumption.
So, dyan ka na, girl, kapag pagkauna, pag naka, ano ka, sa kakalulubo, Nakakawin na ng kain siya. Sabi mo na lang. Uy, ilang ano.
Sir, kita na po ang aking screen.
Yes, okay. We discuss.
So, bali po, ito po yung aking arrow diagram po.
Ba't gabalig tadang iyong
Ay,
lagay?
wait lang po.
Sasakaling kita ha. Digay dun sa itaas lagi at sa ilalim ang efficiency. Diba, gumawa ng ibang drama. Hindi kikita mo rin akin. Oh. Oh, digay ari. Oh. Diba,
Sige po,
hindi
sir.
mo nilagay sa ilalim. Huwag mo ilagay. Ang ilalim may efficiency. Ang nasa ibabaw, yun yung iyong parameter.
Okay po, sir.
Itong
Sorry po.
magagawa ng ano para hindi malito.
Ay po. Bali, ano na lang po ako sa derivation po ng mechanical efficiency.
O, ilagay mo ng bago, sulat mo.
Sige po, sir.
Ayaw ko ng ganyan. Pagdating sa exam, malito ka dyan. Kukopyahin na lang, hindi mo pa nakopya. May drama ka pang Adrian, ikaw muna. Sige, ikaw ang sunod.
Sige po, sige.
Diyos ko po, aring si Dean Abraham.
Kaya lang po.
Share your screen. Naubos ang oras natin ha. Marami pa tayong didiscusin. We have to finish our diesel electric ngayon.
Sana po ba, sir? Bale, ito po, para po sa mechanical efficiency po, tsaka po para sa generator efficiency.
Mm.
Para po sa mechanical efficiency po, kasi po nakalagay po sa arrow diagram po yung yung 1 over HRI at saka 1 over HRD po. Bali, yung 1 over yung brake heat rate at saka 1 over indicated heat rate po. Tapos po, ang mare-reciprocal po sila kasi nga po ay 1 over po sa heat sa kanya giving MI times HB po over MB times HB po. Tapos makakancel po yung HB, matitira po yung MI at MB. Bale, given po sa mga formula po kanina ng MI na 3,600 mF all over IP, tapos ang MB naman po ay 3,600 mF all over BP po. Makakancel po yung dalawa po. Tapos po, mababaliktad po ng reciprocal. Tapos mangyayari po ay brake power over indicated power po times 100. Tapos
How
para
about
naman po
your generator?
sa generator naman po, magiging, base po sa arrow diagram, magiging 1 over combined heat rate po at saka po brake heat rate po. Tapos po, ma-reciprocal po ulit sila, magiging MB times HB over MK times HB po. Makakancel po yung HB. Matitira po ang MB at MK na ang formula po ng MB ay 3,600 mF over brake power po at saka naman po 3,600 mF over EP. Tapos makakancel po yung 3,600 mF po. Ang matitira na lang po ay EP times BP times 100 po.
EP over.
EP over BP times 100 po. Ako.
Yan. So, yan yung derivation. Okay. Good.
Hindi po sir.
Yan. So, balik tayo. Nakikita ninyo itong aking ito na. Heat balance. Nakikita na ito?
Wala pa po, sir.
Kita na po.
Meron na po.
Okay. So, kita na. Kita na
Apo,
ba?
sir.
Okay. So, ito yung diesel engine natin. So, pupunta na tayo sa heat balance. No? Ano ba yung mga heat entering and heat leaving the diesel engine? Of course, meron tayong tinatawag na heat supply. Ito yung 100% natin. Ano nga yung heat supply natin kaninang dinefine? Ha? Wait lang at inaayos lang uli ang connection. Nakinig na ninyo ako?
Opo, sir.
Wait lang. Ako magsishare.
Similar na alis. Bukod simil, yun pa lang yung sa akin. Yung wala pa nga, hindi pa umabyo. Malaki yan.
Okay, so kanina, nakikita ninyo yung screen ko. Kita ninyo ito.
Kita po, sir.
Okay, so meron tayong heat balance of the diesel engine. No? So ito yung heat entering at ito yung mga heat leaving. Okay, so meron tayong heat supplied na 100%. Sabi ko kanina kay Janela, ano yung ibig sabihin ng heat supplied? Ano yung equation natin dito? Janela.
Ang
Janela,
definition,
paramdam ka, baka maputol ulit ang internet. Kaya napuputol, hindi ka naimik.
hello
Go.
po sir.
Mm.
Ang heat supplied po natin na equation kanina is product po ng mass of fuel times yung heating value or calorific value po.
Yan. So yun yung ating QS, which is 100%. So yung 100% mo na distribute into brake heat, no? Ito yung ating heat develop. Okay? Ito yung useful energy, kumbaga, which can be converted into electrical power output. Then meron tayong heat carried by the cooling water, heat carried by the exhaust gas, at meron tayong tinatawag na friction, radiation, and other unaccounted losses. Okay. Sabi ko nga sa inyo, maliit lang yung napuproduce nating brake power or brake thermal efficiency. Okay? Usually at most is 34% kapag ka diesel cycle, and the remaining 66% are basically losses. No? So kung 34 ito, yung 66 na di-divide dito or na di-distribute dito sa cooling water, sa exhaust gas, and then of course sa friction, radiation, and other unaccounted losses. Okay, so how can we compute the heat carried by the cooling water? Heat carried of the cooling water can be computed using the equation MCP delta T. No? So mass ng cooling water, CP ng cooling water natin, and then yung change in temperature. Ito yung inlet at outlet. So yung pumasok dito sa engine, galing dun sa ating cooling tower, yun yung cooling water temperature I. Inlet, no? Temperature ng cooling water. This is coming from the cooling tower. So mababa pa ang kanyang temperature. Pag lumabas yung TWO mataas na, no? Inabsorbs na niya yung init, no? The cooling water absorbs heat going back to your cooling tower. So yun yung TWO. So kaya mayroong change in temperature, delta T. Pag kinuha mo yung percent, no, percent heat carried by the cooling water, no, kukumputin natin yung QCW, and then i-divide natin ng heat supplied. So ito yung equation natin again over MFHB. And then from this equation, pwede nating masolve yung mass ng cooling water. Kaya pag nagde-design tayo, we should compute how much cooling water is required, no, to cool the engine. No? How much cooling water is required. So pwede nating makompute using this equation. So usually ang ating mass ng cooling water is in terms of pound per hour or kilogram per second. Okay? So percent QCW times your QS or MFHB over CPW delta T. Okay, so there are two variants, okay, na ginagamit natin sa equation. Kapag ka daw ang MF at saka heating value are not given. So ibig sabihin itong datang ito ay hindi ibinigay, no? Wala kang pagkukuhanan nito. Ibibigay naman sa iyo yung break thermal efficiency. Kanina ginamit natin ito sa ating performance analysis. Break thermal efficiency at saka break power. Okay? So ano ba yung ating relationship doon, 'di ba? EB is BP over MF HB. Kaya pwede nating MF times HB, ginamit natin kanina itong equation na ito, BP over EB. Pagka naman siya ay in terms of kilowatt, no, na sa SI units siya. Ang iyong mass ng fuel ay kilogram per second, ang heating value mo ay kilojoules per kilogram. Kapag ka naman English units, ang iyong brake power is in terms of horsepower, kaya brake horsepower. I repeat, brake horsepower. Imo-multiply mo ng 2545 conversion factor kasi nga horsepower siya. Ang iyong mass ng cooling ng iyong fuel ay pound per hour. Ang iyong heating value ay BTU per pound, no? Kaya may conversion factor tayo dito para maging consistent with the horsepower unit. Okay? I-divide mo ngayon siya ng brake thermal efficiency. So that would be your equation na mawawala are. Ito na yung isa-substitute mo dun sa iyong equation. Sabi dito, these two parameters are not given. Ibibigay naman ang EB and BP. Kaya mangyayari, ang iyong equation ngayon ay mass ng cooling water percent QCW times your brake power over EB. Ito yun. I-substitute mo dun sa MFHB. No? Then CP ng water, delta T. Or in terms of English units, percent QCW, brake horsepower times 2545, EB, CPW, TWO minus TWI. Delta T. So yan yung pwede mong gamiting equation. Ibibigay ang BP, ibibigay ang brake thermal efficiency. Okay, yan. Second variance, no? Hindi daw ibibigay naman ang brake, no? Brake thermal efficiency and then percent QCW. Pwede ka namang mag-assume. Pag hindi ibinigay, you can assume this value, no? Brake thermal efficiency is 30%, pero at most 34%. Kapag ka ikaw ay nagde-design, for design purposes, you will use the minimum value for brake thermal efficiency. Ganun yon. Hindi mo ang gagamitin yung maximum. Nasa minimum ka. Pero pagka losses, you will consider the maximum value rather than the minimum value. Gets? Baliktad. Kapag ka yung useful output mo, pagka design purposes, you will assume the minimum value. Kapag ka naman losses, no, for design purposes, you will use the maximum value instead of the minimum value. So, sa EB natin, sa brake thermal efficiency, you can use 30%, no, instead of 34%. Percent QCW, you will use 32% instead of 30%. So, alin yung 30% and 32% values? These are being recommended by DEMA. DEMA is Diesel Engine Manufacturing Association. So for design purposes, you will use thermal efficiency, brake thermal efficiency as 30%, percent QCW at 32%. Okay, so yan yung isa-substitute mo ngayon sa equation. Percent QCW is 0.32, brake power, EB, 0.3 CPW delta T for SI units. Kapag ka naman siya ay English units, 0.32 pa rin. BHP, brake horsepower, and then 2545, 0.3 CP delta T. Okay? Yan yung ating equation. So, paano natin i-convert siya? Usually, we should convert your mass ng cooling water into volume of cooling water. So, volume flow rate. So, alam naman natin yung relationship, yung density natin. If you're given the density, then mass over volume, so we can compute. No, yung density ng cooling water natin is 8.33 pounds per gallon. We can use it or 1 kilogram per liter. Kaya pwede nating sabihin na volume ng cooling water 0.255 brake power over delta T. Saan galing yung 0.255? Dito yon. Paki ano ninyo? 0.32, no? 0.32 divided by 0.3. Oh, anong value noon? 0.32 divided by 0.3. Oh. Then, nawawala na yung ating CP. Ano ba yung CP ng water? 4.187. So, 0.32 over 0.3 over 4.187. Anong sagot? Dapat ay ito. Tama ba ga?
Tama po, sir.
Yan. About this one, 2714.67 brake horsepower over 8.33 delta T. And then ang iyong BCW is 326 brake horsepower over delta T. O, saan ang galing yun? Saan ang galing? Ito yon. 0.32 times 2545 over 0.3 over 1. Ito yun. Okay, repeat. 0.32, 2545, 0.3, then 1 yung ating specific hit. Tama ba ga?
Tama po, sir.
Divide mo ng 8.33, it will result to 326 brake horsepower over delta T. Tama ba?
Tama po.
Yan. So ang unit mo ng ng iyong volume flow rate ng cooling water in English units gallons per hour. While kapag ka naman SI, it should be liter per second. So yan yung mga standard units natin. Pag nag-specify ka ng volume ng cooling water, it should be liter per second. At kapag ka naman sa English units, it should be gallons per hour. Okay, so we are done with percent QCW. Okay? Next is yung percent QG. Heat loss or heat carried by the exhaust gas. I repeat, QG is heat carried by the exhaust gas or percent QG. Percent QG is QG over QS. No, so yun yung formula. Yung QG natin, we can compute also using MCP delta T. M represents your mass nung exhaust gas natin. CP nung exhaust gas times your delta T. Ang delta T natin is TG, temperature ng exhaust gas, minus temperature ng air. Okay? So, paano natin makukuha yung mass ng exhaust gas? So, magmamas balance tayo sa ating diesel engine. Sabi natin, meron pumasok ditong mass ng fuel. Meron ding pumasok na mass ng air. At meron tayong lalabas na mg. No, mass ng gas, exhaust gas. So, mass ng fuel plus mass ng air is equal to mg. So, yun yung equation mo for mass ng exhaust gas natin. Okay? Another thing, temperature ng ating exhaust gas, syempre, mataas siya kasi nag-absorb na siya, nagkaroon siya ng combustion process. No? Ito yung exhaust gas natin. No? And then, meron tayong air temperature or ambient temperature. Or room temperature. Pwede. So, TG minus TA. Then, heat supplied again is MFHB. Ngayon, method 1. Method 1. Pag ibinigay daw ang higher heating value, ito yung gagamitin mong equation sa percent QG. Idadagdag mo yung latent heat doon sa sensible heat kasi itong MCP delta T is basically sensible heat. No? Paano ba yung sensible heat? The amount of heat required to increase the temperature without change in pressure, without change in phase. No? I repeat, the amount of heat required, no, to increase the temperature or to raise the temperature without changing its phase. Pag latent heat naman, no, the amount of heat required to raise the temperature with change of phase. No, so nagkakaroon ng pagbabago yung iyong phase. So halimbawa nagiging liquid, to vapor. Okay, tumaas ang temperature, na-convert into vapor, from liquid to vapor. So, latent heat yun. No? So, i-add mo yung latent heat of vaporization over MF or sensible heat. So, nadagdagan ngayon. Higher heating value na ang gagamitin mo dito instead of simply calorific value. Kanina, diniscuss natin ang pagkukompute ng higher heating value. Bureau of Standard Formula as may formula. Okay? Pagka naman lower heating value ang ibinigay, so ito lang ang gagamitin natin sa simply sensible heat. Simply sensible heat. Okay? Paano natin kukomputin daw? Paano daw natin kukomputin ang latent heat? Kanina, MW, HFG. Ganun pa rin. Sabi natin your HFG is 2,442 kilojoules per kilogram at 25 degrees Celsius or 77 degrees Fahrenheit, which is equivalent to 1050 BTU per pound. Yung iyong MW is 9 times percentage. Okay? So, yan yung iyong QL. No, gagamitin natin sa pagkuha ng percent QG. No? So, nabuo siya doon. Okay? Pagka higher heating value. Okay. So, ito yung ating discussion. O, nakikita ganin nyo ito?
Yes, boss.
These are just reiteration ng ating previous discussion. Heat equivalent to brake power of engine. Ito yung QB. Heat carried away by cooling water. Yung QCW. Heat exhausted with the exhaust gas is QG. Unaccounted losses. So including friction, radiation. Okay? Ngayon, kung titingnan natin in a pie chart, no? Sorry. This is not the one. This one. Okay. Yan. So ito na yon kasi ito yung ginamit ko sa discussion. Kaya meron na siyang pula-pula. Okay? Ito kasi ay ano. Okay, so ito yung kanina nating diniscuss. 100% supposed to be yung total heat supplied. Heat loss ng cooling water, heat loss ng exhaust gas, unaccounted losses, and then ito yung Q equivalent to brake power. Ito yung ano ito? Ito yung useful. No, ito yung useful heat natin. Useful heat. Sabi natin, kapag ka gasoline engine, 25% ang kanyang useful heat. Samantalang kapag ka diesel engine, 34%. So, mas mataas. At most. Kapag ka naman ang iyong heat carried ng cooling water, gasoline engine is 27%, while in the diesel engine, we have 30%. Heat carried ng exhaust gas is 26% for diesel and 30% for gasoline. And other friction, radiation, and other unaccounted losses. Sa diesel engine, that is 10%, and gasoline engine is 18%. So yan yung ating heat balance. More or less, yan yung na-measure natin. No? Theoretically. Pero sa actual, mas mababa pa dyan, syempre. Okay? So yan ang pagko-compute. Kanina, pinakita ko na sa inyo. Yan. So pag gumawa ka ngayon ng heat balance sheet, so ito yung heat supplied, ito naman yung heat expenditure. So these are basically losses. No? Ito yung losses at saka yung useful heat. No? So dapat 100% siya. Okay? Dapat siya ay 100%. Next. So yon. O, makinig kayo.
In this video, we'll try to understand how to draw heat balance sheet.
O, pakinig ninyo yung Indiano.
Yes po, sir.
In case
Okay,
of
go.
IC engine. Now, the first part is the total or gross heat supplied due to combustion of fuel.
So this is the procedure on how you are going to do your heat balance sheet. Okay, go.
And it is given by Q is equal to mass flow rate of the fuel multiplied by the calorific value of fuel. The mass flow rate of the fuel can be expressed in terms of kg per minute and calorific value of the fuel can be expressed in terms of kilojoule per. In the case of the gaseous fuel, then it will be meter cube per minute, and the calorific value will be in kilojoule per meter cube, as shown over here. Now this kg will get cancelled up, and here we are drawing the heat balance sheet on kilojoule per minute basis. Here also this meter cube and this cubic meter, it is getting cancelled out, so it is kilojoule per minute basis. So in this particular case, we are drawing the heat balance sheet on kilojoule per minute basis. Now the calorific value of fuel, suppose we take into consideration the meaning of this particular calorific value of fuel, then kilojoule per kg. So it means that by burning 1 kg of fuel, how much amount of the heat that is liberated is known as what? The calorific value of fuel. In case of petrol, we are having petrol or diesel, the average value of the calorific value of fuel is 44,000 kilojoule per kg. Now this heat that we have supplied is used for various purposes, and that is known as the heat expenditures. So suppose this is 100%, and out of this particular 100%, how the amount of heat that is utilized, and that is known as what? The heat balance sheets. The first part is the most important part, that is the useful work that we are obtaining. That is nothing but in the form of brake power. So first part is heat equivalent to brake power. The second part is the heat carried away by the jacket cooling water, which is circulated around the engine cylinder and to cool the engine cylinder, and it is given by mcp delta T. So it is mass of water, third part is the heat carried away by the exhaust gases. So that is also in the form of mcp delta T. The gases which are going out from the silencer of the engine, they are also carrying certain amount of heat with them. And finally, the heat unaccounted for, that is some part of the heat is not calculated by using these particular formulas that we have used, or there is some friction, error, radiation, etc. So from total value, if you subtract this A plus B plus C, then you will get this heat that is unaccounted for by difference. Now suppose the brake power is expressed in terms of kilowatt, that is kilojoule per second. And now, as we have seen earlier, that here we are drawing the heat balance sheet on kilojoule per minute basis, and kilowatt is nothing but kilojoule per second. Then we have to multiply whatever the brake power of the engine by 60, so that it will get converted to kilojoule per minute. Heat carried away by jacket cooling water, just now we have seen that it is mcp delta T, where m dot w is the mass flow rate of the jacket cooling water in kg per minute, because we are drawing the heat balance sheet in kg in kilojoule per minute. CPW is the specific heat of water. If it is not mentioned in the example, you can assume the value as 4.186 kilojoule per kg Kelvin or 4.187 kilojoule per kg Kelvin. And T2 minus T1 is nothing but what? It is the rising temperature of the jacket cooling water, either in centigrade or in Kelvin. The next part is the heat carried away by exhaust gases. So that is the mass of exhaust gases or mass flow rate of exhaust gases in kg per minute. Now there are two ways by which we can calculate this mass flow rate. We know that the exhaust gases, they are formed by the combination of air and fuel mixture. So if that value or those values are given in the example, then we can express the mass of exhaust gases as a combination of or addition of mass flow rate of air plus mass flow rate of the fuel. Or if air fuel ratio is mentioned in the example, then it is given by CPE is nothing but the specific heat of exhaust gases. And if that value is not mentioned, then you can assume it as 1 kilojoule per kg Kelvin. TE is the temperature of exhaust gas or exhaust gases which are going out from the engine cylinder in centigrade or Kelvin. And TA is the temperature of the ambient air or surrounding or test room temperature in which the trial is carried out, either in centigrade or Kelvin. So we can say that the total heat that is supplied is using A, B, C, and then this D. So out of this 100%, the heat that is utilized in this particular way. Now let us represent all these things in the tabular form. So the first part is the total or gross heat supplied. So that is Q, kilojoule per minute. You have to write down the same value over here and it is 100%. Now the heat expenditures. Out of this 100%, how the heat is utilized. So first part is heat equivalent to break power. Suppose that value is A. Second part is heat carried away by jacket cooling water. Suppose that part is B. Similarly, heat carried away by exhaust gases is C and heat unaccounted for by difference it is D. The summation of this A plus B plus C plus D that must be equal to the total heat that is supplied and the percentage must be 100. So let us see how to find out these percentages. So whatever the value that you get, suppose this A divided by this Q multiplied by 100 will give you how much percentage of the heat is equivalent to break power. Similarly, B divided by total heat supplied multiplied by 100 will give you how much percentage of the heat, total heat is carried away by jacket cooling water. This value will represent how much percentage of the heat is carried away by the exhaust gases. And finally, this particular term will represent how much amount of the heat is unaccounted for by difference. So in this way, we can prepare the heat balance sheet. In the next video, we'll see how to solve the examples on heat balance sheet. Thank you very much for watching.
Oh, next. Oh, ito ay example ng heat balance calculation. Oh.
In this video,
Ah,
I discuss how to
bigay
solve
ko
the
lahat itong
numerical of
module na ito sa
heat
inyo.
balance
Don't
sheet
worry.
of the engine. In these examples, we find out what is. In this video, I discuss how to solve the numerical of heat balance sheet of the engine. In these examples, we find out what is the heat supply and what are the heat distributed means heat equivalent to brake power in cooling water in exhaust gas and unaccounted heat losses. So first we understand the problem statement, then after given data, and then after solving the examples. So a two-stroke diesel engine was motor when energy meter reading was 1.5 kilowatt. Then the test on the engine was carried out for a 1 hour. Means the engine is run for 1 hours and the following observations when records. So first we just go to the problem statement, then after I discuss the given data and how to convert given data in the proper units. First one is 1 hours means by default fuel is 1.5 kg per hour means in a 1 hours 2.5 kg diesel is used. CV of the fuel means calorific value of the fuel is 40.3 megajoule per kg. Cooling water use 818 kilojoule per hour. Rise in cooling water temperature, that is a 10 degree centigrade. Rise of cooling water temperature means in a input suppose the temperature is 70, then in output it is the 80 degree means directly difference is given. Specific heat of water is 4.2 kilojoule per kg Kelvin. Exhaust gas temperature is 345 degrees centigrade. Room temperature 25 degrees centigrade means it is the atmospheric temperature is 25 degrees centigrade. Air fuel use is 32 jam 1 means suppose 1 kg fuel is used, then the 32 kg of air is used. Specific heat of the gas CPG is equal to 1.05 kilojoule per kg Kelvin. Now through the heat balance sheet, indicate unit in kilojoule per minute. Okay, means we need to convert all this whatever we find out the heat. It is need to convert in kilojoule per minute. Okay, and basis on also on percentage basis means when we see in the table we need to show the percentage. So during the heat balance sheet we study the amount of percentage means brake power is 25 percentage, amount of heat loss in cooling water 27, heat loss in exhaust. So we also need to find out the percentage. Now what are the given data? First is the friction power. Okay, so friction power is 1.5 kilowatt. Then after torque is given 120 newton into meter, no need to any conversions. RPM is given 600 revolution per minute. Mass of fuel 2.5 kg per hours. Here hour is not written, but we commonly taken because this is practical engine is running for a 1 hour. Cooling, then after CV, calorific value 4.30 into 10 raised to 3 kilojoule per kg. Cooling water use MCVW 818 kg per hours. Cooling water temperature difference, outlet temperature is minus inlet temperature of water is 10 degrees centigrade. Specific heat of water 4.2, exhaust gas temperature TGO 345. Room temperature T at 25 degrees centigrade. Mass of air open mass of fuel is equal to 30 because here air open fuel is given, okay, means 32 divided by 1, so answer is 32. Specific heat of gas 1.05 and we need to find out the various heat balance means what heat supply, what is the brake power, what is the heat loss in cooling water, what is the heat loss in exhaust gases and unaccounted losses. Now before moving ahead, I request to like the video and subscribe the channels for watching the more video related to mechanical engineering. You also visit the playlist for watching the various video related to mechanical engineering, or also the link is provided in the description. So here we use this given data. So first we find out heat supply. Okay, so energy supplied to the engine it's by combustion of fuels means what amount of the diesel is supplied, its combustion is takes place and due to combustion some amount is it is released. So it is the MF means mass of fuel into CV. So what is the MF is given, we check in this given data here. MF is equal to 2.5 kg per hour. Okay, and calorific value 40.3 into 10 raised to 3 kilojoule per kg. Okay, now here why we divide by 60, because 2.5 kg per hour is given and we need to find out it minute. So we convert the mass of fuels in a minute, that's why we divide by 60. Okay, and CV is 40.3 into 10 raised to 3 because the CV is given in the megajoule but we need to convert in kilojoule. Okay, so what is the unit of this QS? So we know that the units of mass is kg per hours and CV is kilojoule per kg. So kg is cancelled, so unit is kilojoule per minute because we here divided by 60. So answer is 1679.16 kilojoule per minute. If we not divided by 60 then answer is kilojoule per hours. Okay, so then after you also divide by 60 then answer is same. Okay, so here we return the answer QS is equal to 1679.16 kilojoule per minute. Now this is only one equation. First is energy equivalent to brake power. Brake power means power available at the output shaft or a crankshaft. It is known as the brake power. So for a brake power, dynamometer is used and this equation is 2 pi nt by 60. So here 2 pi, what is the n is given? It is a 600 rpm. Okay, so it is a 600 rpm. So here we written 600. What is the torque? That is a 120 newton into meters. Again divided by 60. Then answer is coming in a seconds. Okay, means here we not divided by 60. Then answer is only in a by default in a minutes. Okay. Now what is the unit of this brake power? So n unit is the RPS and it is Newton into meter. Okay. So answer is 7.5 39 into kilowatt. Kilowatt means it is a kilojoule per second. Okay. Now here we need to divide it by, multiply with the 60, then we get the answer in kilojoule per minute. Or simply we cancel this 60, then we directly get the answer in kilojoule per minute. Okay. So heat energy in a brake power is 7.59 into 60. So it is a 452.34 kilojoule per minute. Why we find out kilojoule per minute? Because in an example, they say that to find out in kilojoule per minute. So here Q brake power is 452.34 kilojoule per minute. Second is heat lost in the cooling waters. So which equation is used? Heat lost is equal to mass into Cp into change in the temperature difference. Again here the Cpw is not written, but we need to multiply it. Okay. Now mass of the water is 818 kilojoule per hours. Okay. But we divide it by 16 and it is converted in kilojoule per minute. Okay. What is the specific heat of the water? It is given 4.2. Suppose in some example it is not given, then we consider 4.187. And the change in the temperature is given 10 degrees centigrade. So here it is put as a 10 degrees centigrade. Here we not need to convert in Kelvin because it is the difference. So answer is coming the same. Okay. So answer is 572.6 kilojoule per minute. So here you see that is our unit of mass is kg per minute into Cp kilojoule per kg kelvins, and this temperature difference is also in Kelvin. Okay. So this Kelvin is cancelled and the kg is cancelled. Then remaining is kilojoule per minute. So here we mention in the answer. And the third one is the energy lost by the exhaust gases. For that we use the
Okay, dito, MCP delta T, nawawala yung CP dito, kaya meron yung 4.2 times yung delta T na 10 degrees Celsius. MCP delta T, nawawala yung CP ha. So, pero 4.2 dito inilagay, okay?
the calorimeters, and QE is equal to mass of gas into specific heat of the gas into temperature of exhaust gas at the inlet of calorimeters minus final temperatures TF. But mg is not given. Okay, in this case here you see mg is not given in the data. Mg means mass of the exhaust gases. So mass of the exhaust gases is equal to mass of the air plus mass of fuels. Then after what we doing? We take the MF common. Okay. So when we take MF common, so here MF is not available. So we need to multiply and divide it by MF. Then after the MF is common. So MA is divided by MF. So this MF is getting common. So it is 1 is remaining. Okay. Now here you see mass of the fuel is given. Here ratio of MA upon MF is given. So we are able to find out the mg. So we putting this value. MF is equal to 2.5 in bracket MA upon MF 32 plus 1. So answer is 82.5 kg per hours. Okay. Now we putting this value in the equation of Q Eg. So mg is equal to 82.5. It is in hours. Then again we need to divide it by 60. CPG is given 1.05 kilojoule per kg Kelvin, and temperature of exhaust gas, that is a 345. Okay, this is a temperature of exhaust gas is given, that is directly supplied to calorimeter. So it is by default input of TGI. So it is a 345. Atmosphere temperature is 25. Okay. So here both are in centigrade. Okay. But we need to convert in Kelvin, but it is in a form of difference. Then it is taken in the same. So it is written here 462 kilojoule per minute. And the last one is the heat to unaccounted losses. After this find out of the heat of unaccounted, we make the table of heat balance sheet. So Q is equal to what is the supply, that is a QS minus Q brake power minus Q of cooling water minus heat energy losses in exhaust gases. Okay. So we putting this all this value and see simply calculate. So it is a 192.22 kilojoule per minute. So now we use this table for making the heat balance sheets. So here I putting this answer. Okay. So first we written what is the heat supply. Heat supply is 1679.16 kilojoule per minute. So it is the 100% because it is only one heat supply is that. Now then after we make the heat distributed. First heat distributed is equivalent to break power. So what is the answer of equivalent to break power? 452.34 kilojoule per minute. Now how to find out this percentage? So 452.34 is divided by 1. Sorry. This answer is divided by the heat supply. Okay. And then multiplied with 100. So you get the answer is 26.94. Then next is in cooling water. Cooling water, the amount of heat rejected 572.6. So 572.6 divided by 1679.16 into 100. Then you get the percentage. It is the 34.1 percentage. So here you see we supplied the 100% of the energy, and out of 100 only useful is 26.94. 34.1% is going in the cooling water. Now next we find out how amount of energies go to the exhaust gas. So in a exhaust gas it is 462. So 462 divided by 1679.16, then we get the answer 27.5. Means out of 100, 27.5% energy is go to the exhaust. And last one is the unaccounted. Unaccounted is 192.22. It is divided by 1679.16 into 100, then we get the percentage 11.46. Now we make the total. So this total of the heat distributed is by default equal to the heat supply. Okay, and all this summation is equal to 100, means 26.94 plus 34.1 plus 27.5 plus 11.46 is equal to 100. So all are the same. So thank you for watching this video. If you learn something, then like the video, subscribe the channel, comment on the video, and share with your friend.
Okay. Calculation, you will notice on how we computed the heat equivalent, no, the break heat or the break power, and we computed also the heat carried by the exhaust gas, heat carried by the cooling water, the heat supplied, and of course the other unaccounted losses. Okay, so let's go back to our slide, original slide. Nakikita ninyo ito? Nakikita baga? We are on the last part of the diesel engine performance. Okay? So, ang i-analyze naman natin, napapakinig pa ganinyo, are you still there?
Yes po, sir.
Apo, sir.
Okay, so ang performance analysis natin ngayon would be on the last part if your diesel engine is installed at an altitude or higher altitude. No? So, if you are given an elevation, no, ano ba yung performance ng iyong diesel engine? Is it the same power developed at this given elevation or there is a change in power developed? Halimbawa, ikaw tatanungin ko, if I will ask you, Hana Suset, nariyan kapaga. Hana,
Yes po, sir.
ano yung magiging performance ng diesel engine in terms of the power developed kapag siya ay nasa mas mataas na elevation above sea level? Nag-i-increase ba o magdi-decrease ang performance niya? Increase,
Mag-i-increase po
decrease.
ang power
Okay?
develop.
Ano,
Increase
ano?
po.
Ano?
Increase po.
Increase. So, ang sabi mo, kapag ang iyong diesel engine ay naka-install sa mataas na elevation, the power develop increases. O, ikaw naman, J-Lo, Agila. Nariyan ka ga, J-Lo. Oh, increase, decrease. Ano? Decrease. Oh, ikaw naman. Jenaline. Jenaline.
Decrease po, sir.
Increase, decrease.
Decrease po, sir.
Ano? Chris. Increase,
Decrease
decrease,
po.
Chris. Chris na lang, napapakinig ko din eh.
Low po, sir.
Increase, decrease.
Decrease po, sir.
Decrease. Okay. Oh, ikaw naman. Ikaw naman, John Ray Umali. Increase, decrease.
Decrease po.
Decrease. Yan. So, ang tamang sagot ay decrease. No, bababa yung performance ng iyong diesel engine kapag siya ay nag-ooperate sa mataas na elevation. Okay? So, ito yon. Ang equation natin, ito yung power developed at a given altitude is equal to power developed at sea level, no? Times, meron tayo ngayon ditong pressure factor at meron tayong tinatawag na temperature factor. So nagbabago yung pressure natin, nagbabago yung barometric pressure natin at a given altitude, at nagbabago yung temperature natin at a given altitude. So ito yung multiplier natin, no? Kaya ang nangyayari, sabi dito, for every 1,000 feet ascent or for every 1,000 feet altitude, there is corresponding decrease in pressure of approximately 1 inch of mercury. Okay? So yan yung iyong pagbabago doon sa pressure natin, sa barometric pressure for every 1,000 feet. Okay? For every 1,000 feet ascent, there is a corresponding decrease in temperature of approximately 3.6 degrees Fahrenheit or 3.6 Rankine. So, nagbabago rin yung temperature, bumababa rin. Okay. So, kung ang barometric reference pressure natin in terms of inch of mercury is 29.92, so ano yung equation natin? 29.92 minus 1 inch of mercury for every 1,000 feet elevation. So, pagka ibinigay sa iyo, let's say, 1,500 feet over 1,000 times 1, ima-minus mo ngayon sa 29.92. And obviously, your B decreases. So, ito na yung bago mong barometric pressure at a given elevation. Na-incorporate mo na yung kanyang change in barometric pressure. Ganon din yung iyong temperature, no? So 520, bakit 520? Ang reference kasi is 60 degrees Fahrenheit plus 460 kaya naging 520 kasi Rankine minus 3.6 degree Rankine or Rankine for every 1,000 feet elevation. So ito yung multiplier natin. So bababa na, hindi na siya 520 at a given elevation. Gets? Ngayon kukuhanin mo ngayon yung B over 29.92 times square root of T over 520. Ito na yung iyong pressure factor, temperature factor. Imumultiply mo dun sa power developed at sea level. Kaya magbabago ngayon and obviously your power developed at a given elevation decreases. Okay? Yan. So, ngayon, let us take this example. You are required to find the power which a 2.5 megawatt diesel engine can develop at an altitude of 1,981.2 meters, taking into consideration A, the pressure change alone, and then B, the pressure and temperature changes. Okay, so for letter A, ang gagamitin mong equation ay ito. P is equal to PS times B over 29.92. Ito ay wala. Hindi mo i-consider ito. So this is negligible. So meaning 1. Ito. Walang pagbabago din eh. Sa letter B, gagamitin mo lahat itong equation na ito. PS times B over 29.92 times square root of T over 520. Okay, go. Yung ang itry. So binigyan ka ngayon dito ng meter. So i-convert mo ito into feet. No? Para magamit mo yung ating equation. Sige, go. Go. You compute for the power developed. P. Yung P. Nariyan paga kayo. Nariyan paga.
Apo, sir.
Apo, sir.
Ay, gutom na kayo. Gutom na kayo. Hmm. Ikaw, Jose, Solo, de las Alas ang magsosolve ng letter A. Ikaw naman, Biko, ang letter B. Ipakikita mo ang solution. Go. Pero yung iba, mag-solve din ha. Kaya tatawagin ko isa-isa maya-maya. Oh, Jose Solo, anong nangyari na sa iyo?
Wait
Napaka
lang po. Pipicturean lang po.
share na, i-share mo na ha. Picture
Opo.
and share. Napakadali naman ang solution niyan, pambata. Kahit Bambini, no? Ay nakakapag-solve niyan. Pag hindi mo yan na-solve, ilipat kita sa Bambino. Nasaan ang iyong screen?
Wait lang po, sir. Kita na ka.
Hmm.
Yung
Mega, mega ngayon sa Lucy, tinangkas mo na ng pagkatangkas-tangkas. Dahil hindi mo inisa-isa. So, na
yun lang po.
sinubstitute mo na ng buong-buo
So,
doon.
yung ano po.
Bago
Yung,
mali naman. Kaya hindi mo na kinompute ang B. Lahat-lahat mo na. Bago mali naman ang pakapag ano. Samantalang aring factor na ari buo hanggang din sa numerator mo, yung 29.92 yung bracket mo dapat, di ka?
oh,
Kagulo. Baga hindi mo muna isa-isahin. Computein mo muna yung B. O,
sige.
bago substitute mo yung B. O, para maliwanag.
Sige po, wait lang po.
Oh, tama ba ang sagot na rin? Ano gari? 1.95 points. Ano ga
Hindi
yun?
po. Wala pong point.
Oh.
1.95.
Pag kami dalawang decimal places, wala nang problema sa akin yun. May katotoo bang hahabulin yung pagkakadami ng decimal places? Kukopyahin lahat yung nasa calculator. 1.956850276789101112. Diyos ko, ano kang haba? Ano kang haba? Diyos ko po. Kayo naman na. Kayo ay matatanda na, ay wag na ninyong ilagay yung utak ninyo doon sa mga ganong kailangan kumpletuhin ninyo. Hindi ka kayo marunong mag-round off. Diyos ko po. Ito na may design. Diyos ko po. Oh. Discuss. Ano bang nangyari na din sa iyong ari?
So, yung P sub S po ay yung 2.5 megawatts.
Oh.
Tapos yung B naman po yung nasa taas. Edi ang 29.92.
Simula ka muna sa elevation. May kagagat.
So, yung elevation po ay
ang diesel engine po ay naka-install at a given elevation.
Yun po, installed po siya.
Para ma-establish muna na ang engine mo ay nasa certain elevation above 1,000 feet. Kasi kung yan ay wala naman at nasa sea level, ay wala na tayong pag-uusapan. No?
So, installed po siya at 1,981.2 meters. Tapos, kinonvert naman po siya sa feet. So, 6,500 feet po, which is above 1,000 feet po. Tapos, yun po, in-input na lang po dun sa, para po makuha yung B. Tapos, yung sa temperature naman po ay hindi na po sinama.
Negligible sa letter A ang change ng temperature. Okay. Oh.
Kaya
wala mo na dapat ipakita yung square root of T over 520. Hindi mo na ipakikita yun.
So, ang lumabas pong sagot ay 1.
Mamaya may gagawin mo ay square root of T over 520, ginawa mong 0, ay di 0 lahat yan. Anong sagot?
1.96 megawatts pong sagot.
So, yun ang naging So, from 2.5, naging 1.95 na siya kung i-consider mo yung pressure change. Letter B, parehong i-consider both pressure and temperature. Nasan yung girl? Nasaan yung girl lalo? Sino yung girl lalong yung aking tinawag kanina?
Ngayon po, sir, ipe-present ko lang.
O sige, share mo ang iyong screen.
Kita na ba po?
Oh.
Sa letter B po ay
Mm.
ina-account po lahat po nung nandoon sa formula. Di sinulat po muna po yung formula and then yung formula po ng B and T tsaka yung given po dito.
Okay.
Ang bigay po na elevation ay 1,981.2 meter and then yung pressure naman po at sea level ay 2.5
Ano
megawatts.
bang pressure ha? Sakaling kita ha?
May power develop po pala at sea level.
Yan. Huwag mong paglahukin. Kaya nga B ang pressure ngayon dyan para nga hindi magkalito-lito. P power, B pressure, barometric pressure. Okay, go.
Para po sa barometric pressure, ito pong 29.92 minus 1 times elevation over 1,000 feet. Para po makancel po yung feet, yung elevation po na given ay i-convert po muna sa feet gamit po yung conversion factor na 3.281 feet is 1 meter. Then ang makukuha po dito ay 23.4196828. In-store ko po siya sa A po sa calculator para po hindi po makat yung values. Then next po, yung i-consider po ang temperature. Ito po yung formula. 520 minus 3.6 times elevation over 1,000. Same po dun sa nauna. I-convert din po yung elevation sa feet para po makancel po ito. And then ito po yung nakuha 496.5988581. In-store ko po siya sa letter B naman po ng calculator. Then isa-solve na po, ibabalik lang po yung na-compute na values dun po sa formula. Di 2.5 megawatts times yung in-store ko po kanina sa A na barometric over 29.92 times square root naman po nung in-store ko naman po na value na B over 520. Ang makukuha po ay 1.91 megawatts po.
Yan. So, yan yung sagot. Bukas mo baba pa ang power develop nung i-consider mo ang temperature. From 195 from 1.95 to 1.91 megawatt. Okay, so obviously, no, bumababa ang performance ng diesel engine kapag siya ay nasa altitude above or equal or above 1,000, no? 1,000 feet. Okay? So, yan. So, yan ang ating last performance analysis. Okay. So, ito na yung gagawin ninyo. Paki-screenshot. Screenshot ninyo. Screenshot ninyo ito. Hintay muna ha. Ano ko muna yung direction. Pakikopya 20, 24, 29, 30, 34. 20, 24, 29, 30. Oh. 20. So, ito yung nasa 20, 24. Paki-screenshot 20, 24. No? Paki-screenshot 20, 24. Then 29. Ang 29 nasa sunod na page. 20 lang ang kukuhanin mo dito. 20, 24. Then 29, 30, 34. Yan, 29. Ito yung 29, 30, 34. 29, 30, 34. Okay, okay. So, yan yung gagawin ninyo. O, yung magpapakonsult sa project sa capstone, Pwedeng pumunta din after our meet. Provide ko sa inyo yung copy ng ating slides kanina. Sige.